Hello everyone, this is Deepak Joshi, and today we are going to solve another problem statement from LeetCode, that is 62 unique paths. This I want all of you to go through this particular problem statement. States that we have given we have a m cross n grid, that means a 2D array, uh, and there is a robot which starts from the top left corner of that matrix, and we have to move that robot to the bottom right corner, and we need to find out the robo we need to find out what return the number of possible unique paths. So basically we have to find out number of unique paths, like how that robot is going to reach the bottom right corner. Let us take this example, 3 and 2. That means three rows, am I right? Yes, three rows and two columns. Okay, one, two, three, 2, 4, 5, 6, two column. Yes, two columns. Okay, and 6, 7. Yes, three rows, two columns. Oh my god. Now the total number of ways to move call that robot are three. Here it mentions, and we are only allowed to move down and right only. So let's say I'm at one. I can reach two, then right, down, down. That is how I'm going to reach the bottom right part. And let's say for one path has been calculated. Let's say I move down, down, then right. Second path to reach 7, and one probable path to reach bottom right is down, right, down, DRD. Yes, so there are total three paths to reach bottom right part. How we are going to approach this particular problem statement? um, Recursion can be used here. Why intrinsically I mentioned recursion is because whenever there is a repetition happening, like we need to check whether the robot is going to move rightwards or downwards, uh, is all dependent on is all recursively happening or repeatedly happening, and in repeated test cases or in repeated cases we use recursion. So we are going to use recursion here. We have only m and n, no data available regarding the matrix, only the number of columns and number of rows and number of columns. All right. Then how we are going to get that? Okay. What we can do is, like, we can have a private recursion function, and it will be int recur recur function int. It will represent the ith current index of the robot, the current row of the robot. J, it will represent the current what the current column of the robot, and int n. Like I don't like to mention that m is m row. I mention n as row and m as column. Please remember that. Like, if you move forward to the video and you forgot, oh, I forgot to mention, I forgot to edit n and m, that will be a confusing case for you. So to resolve that, what you can do is try to code by yourself by understanding the problem statement, and let me type all the code, understand that, and then try to write it by your own without taking a look at the solution. Great. And uh, int m. All right. Now what we can do with this particular recursive function? Let me call this recursive function. I am going to call recur. And initially the robot is at 0th row, 0th column. The number of row is n, number of column is n. Hence, I'll do this. Okay. Okay. So first of all, what we need to check is base condition. Base condition is if the robot is at the bottom right. If yes, then return one, because in that case we have to figured out one path to reach from the top right to the bottom left. Yes. How we are going to calculate that? Very easy, guys. Very easy. Like, if n minus one, my robot's index is I, means my robot is at ith row, and if that is equals to n minus 1th row, yes, that means my robot is at that particular row. Okay, n minus 1th. Why Deepak? Why n minus 1th and not nth? Because I am, or it is a standard rule. It is a standard rule that expects number of rows, number of columns to be zero base indexed. Yes. And j is equals to m minus 1. As simple as that. If that is the case, if that is the case, I am going to return 1. Simple. Yes. Great. What if, let's say, I somehow move, what is going to happen is I need one more condition here. Why, Deepak? Let's say, yes, let me take you an example. Let's say, Rn is 3 and Rm is 2. All right. And currently I am at in row 3, but I was at index 1. Yes. In that case, I'll be deciding to move forward with right or a down. And let's say in next move, I move downwards. But there is no row that has index 4. That will be an edge case. And how we are going to tackle that is by writing one more case here. How we are going to write that? If in any case, like, I becomes greater than equal to n, or j becomes greater than equal to m, if by any chance, simply return 0, because that case is not even possible. Am I right or am I right? I think in that case, I am right, but I am Deepak Joshi. Yay, very bad joke. I'm sorry. Yes. Now, in the else condition, what I'm going to do is simple. What I'm going, array bhai. What I'm going to do is I'm going to return what? I'm going to return a recur of I plus 1. Let's say I move to the next row. If you want to go right first, then just write I j plus 1. But I want to move downwards first. Yes. And then j, and then n, then m. Yes. This is written here because, like, I move downwards. If I keep it as it is, then it is not going to move rightwards in any condition. It is going to move downwards and going to check, oh, did I reached the nth row, nth column? No. It will exceed the nth row, and eventually will return 0. So what do I need to do is I need to create permutation combinations of left and right. All right. That, oh, I move downwards, I should move rightwards in the next condition, or I should move rightwards now. That is, I need to take care of. So what I'll do is I'll simply add a right move here. That is by doing this. As simple as that. So this is our use case. Like, this is our probable solution, recursive probable solution. I hope it works. It should work actually. Let me run, and then we'll figure out. Yes, it has been accepted. Tough time, I know. Keep working, keep hustling. That is what I can tell you, guys. Yes. Okay. 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 We have uh, gotten TLE on this particular problem statement. Okay. No issues. Because we were going through a lot of permutations and combinations. Class 11th. I used to hate this chapter. Not hate, but yeah, like, I uh, was not very much interested in this particular thing. Like, my favorite part was differentiation. I don't remember whether, yeah, I think I don't remember whether it was in 11th class or 12th class, but yeah, I enjoyed doing um, what I enjoyed doing. I enjoyed doing trigonometry, differentiation, integration. Like, my favorite was differentiation. It was easy, I don't know, but yeah, it is the one thing that used to fascinates me. I have solved complete addition of class 12th and 11th. Uh, Class 12th, I don't remember, like, differentiation was there in 11th class or 12th class, but I have solved the complete addition of it. Yes. And we were talking about the TLE. Yes, the TLE has been occurred. Now, how we are going to resolve that? Very easy peasy lemon squeezy, guys. What we can do is, instead of calculating again and again this particular thing, hey, I'm moving rightwards, hey, I'm moving leftwards, what we can do is we can have a DP, dynamic programming. Yes, we can store it in a DP. Like, hey, do we have this particular solution before? If yes, then okay, use that. If no, Let's move forward and calculate that and store it into the DP array. Like simple use case of DP. Listen, guys. I also have not done very tough questions on dynamic programming, but till now, what I'm able to understand is till now what I'm able to understand is DP means, hey, you are calculating so much. Let me store what you have calculated, and in future, if you need the same calculation, I'll provide you that. Use me. If not, then please go ahead and calculate the calculation. This is how DP works. DP stands for Deepak, and P stands for Pyare, Deepak Pyare. Yes. Thanks, guys. Okay. So, where were we? We were talking about DP, how we can use DP here. Oh, man, uh, I, I do not want to say that because I'm going to use DP and I'll say, oh, I hate DP. No, I do not hate DP. Uh, I very badly hate DP actually. I'm sorry. Yes. So, where were we? Yes, we were talking about this particular thing. Like, what we can do is we can have an extra 2D DP array. Why 2D? Like, we can have a single DP array, but it will require much more calculation from our end. Instead of having that, what we can do is we can have a O of n space. Not O of n, O of n cross m space, because our DP will be a 2D matrix, so it will look like something this. मैं किसी का सपना हूँ जो आज बन चुका हूँ सच. Yes, that is how we are going to pass our DP. All right, guys. Okay. It will throw us an error because here we are not passing it. DP. Yes, guys. Yes. Scrub dope. Okay. Yes, and here we need to create a DP as well, like vector of vector inch DP. Yes, guys, and it will be of size n, and vector of inch, it will be of size m initiated with 0. That is what I'm thinking of doing. Like, we can have this particular thing, and no, like not with 0, with -1. Yes, and but if I do this, like let's say I created this, and what is going to happen is, let me think about it. Let me, because I'm thinking right now with you. Let's say I created a DP of size n and m, and it is going to have an access to, okay, nth index. Okay, and do I need extra more? uh, I think I do not need any extra. Yes, I think I do not need. Okay, if we need any extra in thing, then I'll let you know, and we'll see like what we can do. Yes. Yes. Okay. I think we are fine now. Okay. Yes. Yes. Like what I was thinking is whether we need one more, like whether do we need to have the size of the rows and columns as n plus one and n plus one, or n is fine and m is fine. So yeah, like right now what I think is n and m are fine, but if anything occurs, we need to take a look at it, and then eventually we'll solve that. Okay, I think we are good to go here. Okay, so in DP what we generally do is like we check, we add an additional command like, hey, if my current DP of I comma j is not equals to -1, that means I have a solution for you for this particular path. That means simply return that DP of I comma j. Simple, simple, as simple as that. Okay, that means return that. We know that. Okay, we know that we have calculated that for you. Simply do a return of DP I comma j. As simple as that. And instead of directly returning the recursive functions here, what we can do is we need to store like the output of this in our DP of I comma j. So what we will do is we'll store that here. Guys, so this is the solution that I'm thinking it should work. Yeah, like here what we can do is we can have int count equals to this. And one more thing that I am curious about is, like, let's say if we have yeah, like, okay, let me face that error and then We'll resolve that together. We'll try to resolve that together. Okay, okay. Compilation error. It says we are calling it without anything. Okay, then let me call it using DP and check what's happening. Oh, all the test cases passed. Like, what if it is one and it is one? Let me check and run that thing. Okay, eventually it passed for the expected and output. Okay, still, let me run that. Okay, it has been submitted successfully. So yeah, like it is definitely going to work because we have a DP of we have a 2D matrix named as DP of size n cross m, and eventually all our indexes, the ith and jth variables value will lie in the range n and m, because we are already checking. Okay, if I is greater than equals to n, simply return 0. No need to check further, no need to store it into the DP. That means no need to create uh, DP having size greater than n or greater than m. N is sufficient. Yeah, like this is the solution. And I want uh, I want what do I want? I want peace. Yes. I want you guys to share your thoughts. Like, what are you guys currently going through? How is it going? Uh, what are you thinking? What are you planning to do? Like, in which stage of your life you are? Like, you are from first year, second year, third year, fourth year, pass out, having an experience of 1 year, 2 year. If that is the case, I'll be happy to connect with you and understand, like, what are you guys doing and how is it going. We can have a meet, or uh, if you guys are I know it is a problem statement, so very less number of you are going to take a look at it. But if you guys have time, I what we can do is we can have a live stream as well, like in which we can communicate with each other, or we can have a Google Meet as well. I would love to connect with all of you, and yes, love to contribute and would love to understand what's happening, and would love to share what's happening with me and my life as well. Yes. So yeah, yeah, man. Like just go together, understand together, and grow together. This is what I think. Uh, let me know what do you think. Let me know what you think. Yes. See you guys. See you. Take care of yourself. Bye bye.